If we compare Earth all the way up, just how mind-bogglingly huge can the biggest things in the universe get? Jupiter, the king of planets in our solar system, is merely an appetizer at best. Once you bring in the sun, the frame instantly spirals out of control. It is so massive it cannot fit it all, leaving no choice but to pull the perspective back. Yet, the truly absurd things are still to come. What you are about to see next are not just planets and stars, but also supermassive black holes, galaxies, and even cosmic megastructures spanning billions of light years. Let us start with Jupiter first. In the solar system, it is the largest planet. Just how massive is Jupiter? If you shrink Earth into a small ball with a 12 centimeters diameter, then Jupiter's diameter would become roughly 1.35 meters. In other words, while Earth still feels like a model ball in your hand, Jupiter has already grown close to the size of a large exercise ball. However, Jupiter soon pales compared to what comes next. That is because scientists have discovered even more extreme gas giants. Using the exact same scale as before, where Earth is 12 centimeters, this behemoth would be as massive as an elephant or as wide as a small house. It is no longer what you call a normal planet, as it closely resembles a failed star that never truly ignited, merely masquerading in the shell of a planet. To put it plainly, from this point, you can already begin to feel it. Earth is not just small in the universe. It is so tiny it quickly loses any sense of presence. Yet, planets do not truly push the scale's boundaries, but stars. The Sun is the largest celestial body in the solar system. Its diameter is roughly 1.4 million kilometers. If Earth were still that 12-centimeter ball, the Sun would balloon directly to around 13 meters, which is roughly the size of a school bus. In other words, while holding a model of Earth in your hands, the Sun is so massive it has to be parked in the yard. Also, the Sun is not just immense in volume. It accounts for nearly 99.86% of the mass of the entire solar system. All the planets, moons, asteroids, and comets combined are mere rounding errors in front of it. But even so, the Sun will turn out to be just average size later on. For example, Sirius A. It is one of the brightest stars in the night sky, not because it is largest, but because it is close to us. Its volume is 1.7 times larger than the Sun. If we look at it by the previous scale, it would already expand to about 22 meters. But this is still far from exaggerated. Moving further, stars begin to enter the stage of true expansion. Like some red giants, their diameters can already reach 12 million kilometers. This is one future outcome for the Sun. In about 6 billion years, the Sun will also expand into this state, directly swallowing Mercury and Venus, and potentially even swallowing Earth along with them. Slightly larger is Arcturus. Its diameter is about 18 million kilometers. You could even place 25 suns side by side along its cross-section. But even so, in front of a true hypergiant, it is still just a transition. You have definitely heard of this next name, Betelgeuse. It is about 700 times the diameter of the Sun. If dropped into the solar system center, its edge could expand all the way past the orbit of Mars, even approaching Jupiter. This is no longer just the slightly larger star. This is directly swallowing the entire inner solar system together. Yet, Betelgeuse is still not the largest. What is truly absurd is Stephenson 2-18. This is currently one of the largest known stars. If Earth were still that 12-centimeter small ball, the diameter of Stephenson 2-18 would become 38.3 kilometers, which is roughly as high as 3 Mount Everests stacked together. If the Sun were replaced by it, its edge would not stop at Jupiter, but would extend all the way past the orbit of Saturn. Mercury, Venus, Earth, Mars, Jupiter, and Saturn would all be swallowed by it in one bite. If you flew around its surface in an airplane at a speed of 900 kilometers per hour, it would take 1,500 years to finish the flight. At this point, you will find Earth has already become small enough to be a completely negligible dot. But even a star of this magnitude is still not the largest thing in the universe. Making its appearance next is the black hole. Black holes are very special things. It is not always the largest in terms of size, but its mass and density are exaggerated to a completely unreasonable extent. This is a supermassive black hole. Looking at it by our previous scale, when Earth is still a small 12-centimeter ball, it is already close to the scale of the real Moon. But in reality, its scale is roughly equivalent to 40 times the width of the entire solar system. Its mass is equivalent to 66 billion suns. Bluntly, this is no longer just a celestial body. This is a monster that rules everything around it purely by gravity. But TON 618 is still not the largest black hole. Even more exaggerated is the central black hole of Phoenix Cluster A. The diameter of its event horizon is about 590 billion kilometers. If we continue looking at that scale, it becomes a sphere of the diameter of 5,500 kilometers, which is already roughly the magnitude of Mars. Its mass is close to 100 billion suns. How on earth did this kind of thing grow? It is still a question today. At the speed a normal black hole swallows things bit by bit, the universe lacked enough time to feed it to such a large size. No matter how big it is, more exaggerated things lie behind it. Because next it is the turn of the galaxies. Our Milky Way has a diameter of about 100,000 light years. How far can light travel in a year? It is about 9.46 trillion kilometers. Therefore, 100,000 light years is a number so large it is almost impossible to understand by intuition. If Earth were still that small 12-centimeter ball, then the Milky Way would approach the scale of the entire real solar system. In other words, starting from here, all the spheres and stars you could still understand earlier begin to lose their meaning. And the Milky Way is not even that big. The Andromeda Galaxy has a diameter of about 220,000 light years, which is almost twice that of the Milky Way. Further back, there is IC 1101. Its diameter is about 4 million light years. Putting an entire Milky Way inside would make it seem not worth mentioning. But what if even more ridiculous is not a single galaxy, but a huge cosmic structure connected by countless galaxies? This is one of the largest connected cosmic structures currently known. Its span is about 1.3 billion light years. It is not a sphere, nor is it a regular celestial body. It is more like a huge rope stretching out across the universe, connected by string after string of galaxy clusters. If we must describe it, it looks more like a nervous system spanning the universe. Its total mass is equivalent to 200 quadrillion suns. And that is not the end of it, because behind it lies a more exaggerated name: the Hercules-Corona Borealis Great Wall. Its span is about 10 billion light years. What does that mean? It accounts for nearly 10% of the entire observable universe's diameter. If the previous stars, black holes, and galaxies were just big, this thing is so massive it challenges scientists' views on cosmic formation. According to current theories, from the universe's birth to today, theoretically there was not enough time to form such a massive structure. Yet it is right there. Speaking of this, you will discover a terrifying thing. Earlier, we went all the way from Earth, Jupiter, and the Sun, to Betelgeuse, supermassive black holes, and the Milky Way, all the way to a cosmic great wall spanning 10 billion light years. Meanwhile, Earth has been shrinking crazily from start to finish. Shrinking to the end, it is no longer a small ball, nor dust, nor even a single dot. It is merely an existence that can be almost completely ignored. The most shocking part of the universe sometimes is not how big those things actually are. Is that, after comparing all the way down, you will suddenly realize It turns out Earth, which feels so big to us in the face of true cosmic scale, can actually be so small. And this is still just the part we can currently see. Beyond the observable universe, perhaps there are even larger structures, more exaggerated bodies, and harder to understand things, just sitting quietly in the dark. It is just that we today have not seen them yet. I allow not see you in the next universe.